So we're looking at factoring numbers, so factor trees and factor ladders. When you're given a number, you need to recognize that within that number, it has parts to it. And it has things that multiply to give you, the number in question. For example, the marker I have has a cap. It has the piece that writes on the board. It has the body, and so on. So if you were to break it down, you can break it down into its individual components that would essentially multiply to give you the marker. And I know this analogy seems in a sense almost like an addition part too, because you're adding the cap to the marker. But I want you to recognize that numbers can be broken down. It's very important to know how to break them down. It's very, very important. And so factor trees and factor ladders can be used to break numbers down to their prime factors, the numbers that are prime numbers that all multiply to give you the number in question. So let's look at two examples, one with 48 and one with 96. I'm going to use the ladder on 48. Some people like the ladder, some people like the tree. I like the ladder. That's what I grew up working with. But I think that, I could still be friends with those who like the trees, the factor trees. But let's try both and see which one you prefer. So 48, I'm going to start with 2. 2 is the lowest possible number that goes into 48. And 2 goes into 48 24 times. And then 2 again goes into 24 12 times. Notice the pattern. I started with the lowest possible prime number that I know, okay? And if you don't know what prime numbers are, it'd be a good time to review that. But prime numbers are numbers that are only divisible by themselves in 1. So I go 2 goes into 48 24 times, 2 goes into 24 12 times, 2 goes into 12 6 times, and 2 goes into 6 3 times, okay? So notice I just keep going. 2 goes into 48. I put the answer there. So basically 48 divided by 2 gives me 24. 24 divided by 2 gives me 12. 12 divided by 2 gives me 6. 6 divided by 2 gives me 3. And 3 goes into 3 once. You stop when you hit 1, okay? So the prime factorization of 48 is 2 times 2 times 2 times 2 times 3, okay? And so you can write that out, 2 times 2 times 2 times 2 times 3. Or you can write it with the times symbol. That's fine. Okay? But 96, if I'm using a tree, again, you can be flexible. You can use whatever number you want. The same thing in this case. I'm just trying to present a systematic way to do it, so you can always use that for now until you master it and choose a different technique if you want. But the same thing with 96. Let's say I use 2. 2 goes into 96. 2 goes into 9 4 times, and then 6 8 times. And then you notice that at this point it's going to continue down this path. So we have 2 goes in there, we have 24. 2 goes in there, we have 2 and 12. Now I can be creative. I can do 3 and 4, and then I have 2 and 2. So you have 2 times 2 times 2 times 2 times 2 times 3. So 96 is 2 times 2 times 2 times 2 times 2 times 3. You can write that as 2 to the 5th power times 3. Okay? It's important to note that when you have 2 times 2 times 2 times 2 times 2 times 3, so if you have that and you have this, and I ask you what's the greatest common factor between the two, the answer is 48. Because 2 times 2 times 2 times 2 times 3 can go into what we have here with 1 2 left out. So the greatest common factor, the greatest amount that they both share is 48. And then the LCM is actually 96, because 96 goes into 96 once and 48 goes into 96 2 times. Let me know if you have any questions on this. Very important concept as you learn to simplify fractions later on, and you can use these techniques. Have a wonderful day.